So now that you have had a chance to do some maths, it's time for me to do some maths. Oh, let me get ready. I'm gonna go through the question for you. Let's switch on small, and I'm gonna be asking questions. So some rather interesting things might pop up. But if you're really, really confident about how you did the question, then feel free to move through the video. That's the benefit of me not streaming this live to you. You don't have to. You can take in the bits and pieces that you really want or really need. You know that's the flexibility of learning online. So let's see. Let's get started. I'm actually going to pull the screen full size, and let me get it with the panel. Okay, that's perfectly fine there. And let's get going. So first thing, what do you need to think about? What should you have thought about? Well, first thing you should have been asking yourself is, what is the LCD? And don't forget to be looking at the visible thinking panel. Some ideas are going to be coming up there in terms of what I'm doing. So the way you add and subtract fractions is you want the lowest common denominator. And in this particular case, the lowest common denominator would have been the x plus 3 squared. Look at that. X plus 3 goes into x plus 3 squared. X plus 3 squared goes into x plus 3 squared. And well, 1, you can write 1 as anything. That's the benefit of that lovely number 1. So our lowest common denominator that we're going to be using is x plus 3 squared. And we're basing on the fact to add fractions, the only way you can add and subtract fractions is when the denominators are the same. So using those basic ideas. So the lowest common denominator is our new denominator. Okay, we have to write each of these three fractions as fractions over x plus 3 squared. The last one is done for us already. So we start, and I ask you, I've given you a hint there. So if you weren't sure how to start the question, now is your moment where you can pretty much pause the video. Again, that's the flexibility. You can stop me in my tracks now, and you have a go. See if that unlocks and makes it possible for you to do the question. If not, you're watching. Look at the master. First thing, and you'll see these bits coming in green because you don't actually have to write them down, but they're useful to showcase. 1. That 1 is the same thing as x plus 3 squared over x plus 3 squared. That's the idea of 1. Just to divide the number by any number divided by itself will give you 1. So that's 1. And then that 2, and let me make a correction. That is not 2, that is minus 2. We need to take the sign that goes with the number. So what we have there is minus 2 x plus 3 on x plus 3 squared. And why minus 2 x plus 3? Well, what did you multiply x plus 3 by to get x plus 3 squared? You had to multiply the denominator by x plus 3, and same rule as when we have numeric fractions. To make equivalent fractions, whatever we multiply the denominator by, we must multiply the numerator by. So if I multiply x plus 3 by x plus 3 to get x plus 3 squared, I need to multiply my minus 2, the 2, by x plus 3 squared. So I have that's what that's going to look like. And then, well, the plus 2 on x plus 3 squared, it's already, that third term already has our lowest common denominator, so there's no need to rewrite it. Okay. Putting it all together, this is what it's going to look like. And the reason these fractions, the independent parts, were in green, you don't have to do it separately first. You can put everything all together as one, and that's the more common approach. So that is sorted. Now, let me make a bit of space here. I'll just move these to the side so they don't distract us. What do we do next? We've rewritten all the fractions. Let's just recap on what we did there. We rewrote the first fraction using the LCD. We wrote the second fraction using the LCD. And well, the third fraction, it already had the LCD. So those are the pieces that we did there coming up on your screen. Okay. And then we wrote everything as a single numerator. Okay, we wrote everything as a single numerator. Where did we go from there? I see a quadratic. I see brackets. Do we like brackets at the top there? No. The next step that we need to do is we need to expand and simplify the numerator. And again, opportunity here. If you should be confident, actually I shouldn't say if you didn't make progress on the question so far, I would expect that if you're operating at A2 level that you can do the expanding and simplifying. So please have a go at expanding and simplifying the brackets. Stop me in my tracks. You have a go and then see if you do what I did. Okay, so let's just look at what we're doing now. You will be expanding the quadratic. Okay, let me clear all the screens. You're expanding the quadratic, and then you'll be expanding the linear expression and then simplifying the numerator. That's what you're looking at there. I paused to give you a head start so you could have stopped and do. Remember, maths is all about doing. Okay. This is what it's going to look like when you do that expansion initially, and I'm running it in two steps. You know, remember x plus 3 squared is x plus 3 by itself, and then when you fully expand that, that's what I would expect to see, your x squared plus 3x plus 3x plus 9, and then expanding. Just be careful with the linear one. A popular mistake a lot of people make is with the negatives. Just be very, very careful with that. You have minus 2 times plus 3, and a minus and a plus gives a minus, so that minus 6. Be careful. It's so easy. You make a mistake with a sign and that presents a problem there. So just be careful with that. And then at this stage we want to collect all the like terms is what we're looking at doing there, and your final answer should look like this. You should have x squared plus 4x plus 5, and just look at what's happening here. We only had one x squared term, so that was fine. In terms of getting the x term, it was 3x and 3x to get 6x. 6 take away 2 would have given us 4x, or gives us 4x. And then for the numeric term, the constant, we have 9 take away 6. 9 take away 6 is 3, and 3 and 2, 5. So there we go. We have x squared plus 4x plus 5. Are we done? Do you just stop there? Well, not quite. After you have expanded and simplified the numerator, what you need to be thinking about is, can you factorize the numerator? And the reason you need to be thinking about that, and you need to the reason you need to consider that is, well, what happens if I had an x plus 3 in the numerator? If I could factorize that numerator and I get an x plus 3, then the x plus 3's would cancel out. And that could happen. Is it going to happen in this case? Can you factorize x squared plus 4x plus 5? No, you cannot. Okay. So for this particular question where we were asked to express fx as a single fraction, that's your final answer. And this is the process you go through to bring fractions together. Okay, so this is the process you go through to bring the fractions together. I hope, let me just take my glasses off. Yes, you can see I do wear glasses. The reason, and I'll put it on the big panel, the reason I don't wear them when I'm looking at the screen is because, woo, Ooh, see, light to do video, you need a lot of light, and is that like what is it? Cyclops? I can I can the glare. I should actually have uh, uh, glasses with anti-glare, but I'm one of those people, and they get lost. Yeah, I've lost a couple pairs of glasses. So I try not to get all the bells and whistles at the moment. Okay, but so we have the solution to the question. This is an actual exam question, and we really important that last step that we made there, where we were considering if we could factorize the numerator, and we can't. That leads quite nicely on to what was the second part of this question. So we're going to leave this part for a moment, and we're going to look at the second part. So we're going to leave the world of algebraic fractions just for a moment, because it's really useful as we explore this exam style question. What would happen next? What can we tell about x squared plus 4x plus 5? And the next part of the question looked like this. Show that x squared plus 4x plus 5 is greater than or equal to 0. Show. And I want you to have a go at doing that. Okay? Because how we, generally speaking, when we start new topics, new units, we'll always explore a full exam question, and then we'll work backwards to see, to develop all the components that we need to do them. Okay? So you can get that dedicated practice. But this is an exam, they generally put all the topics together. So that was on numerator, x squared plus 4x plus 5. How would you show that? Now, the little thing I'll tell you, and I find this interesting, is I can think of 3 different ways to answer this question. I can think of 3 different ways. I'm looking, it's because of the angles. I'm not ready for this weatherman kind of stuff. I will get there though. But I can think of 3 different ways to answer this question. So, using your knowledge of quadratics, come up with 3 different ways in which you can show that x squared plus 4x plus 5 is greater than 0. And the incentive, when you finish, just have a go. Try it. See what you come up with. I want to encourage you to be willing to try things. And send an email to mattstutor@Raymondson. Scan and send a copy of your work. Make sure you have your name on it. And we'll give you the solution, the full detailed solution. You'll get access to that. That's our gift to you. Okay, and I'll add to that. If you send a solution before the 31st of August, okay, you'll be entitled to a 50% discount. We'll send out a discount code for you. So if you decide to take up one of our tutoring course, then you can get 50% off the basic package by just showing me that you're willing to try. How does that sound? Okay, right. So have a go. It's only going to benefit you, and if you're wrong, we'll show you how. It's fine to be wrong. You learn from mistakes. Have a go. Send your solution. Get it done as soon as possible.